Hello, this is tech demo number two. To begin, we're going to graph the function that was given to us. And I'm using CalcPlot 3D for simplicity because it's easier when doing contours, in my opinion. But we're going to start off, and the function is 1/2 x cubed minus y cubed plus 4xy. Okay. Here's the function graphed, and we can zoom out a little bit. With this function, when you zoom out, you can kind of see it better from the top-down view, but from the sides, you can't see it as well. And that's just what's going on with this function. So I'm going to zoom in a little bit so we can truly see what's going on, and see the overall shape and see that it is kind of like a saddle. Okay, so the next step we're going to do is we're going to create a contour plot. To create a contour plot, you press this red button right here, and then it automatically is going to do it. I'm going to change the color just so we can view it easily. And then I'm going to allow contour labels to be shown so we can see everything. And so I want to show at least 6 contours, and it's showing 11, so this is perfect. So I'm just going to hit create plot. And here we go. Now we have a contour plot over here on the side as well. Um, yeah, so with that, you can see the graph and then with the contour lines as well. And then on the left, you can see the contour plot. And it's vaguely symmetrical in a sense, but it is like curved and it is different. Not entirely symmetrical, but there is some consistency with the direction of the curves. And you can see the z plots are labeled as well. So it's like 0.2, 0.4, 0.6, 0.8, and 1. So that represents the z, and then the x and the y are also. And it is just interesting that this is curved, but it does make sense because of the top-down view of this graph. The next thing we're going to do is we are going to turn off the contour plot. So I'm going to tap that and turn that off. And then I'm going to hit here, and we're going to graph the tangent plane. So the tangent plane I already found. Um, to do this, you're going to add an implicit surface because a tangent line is a surface. A tangent plane is a surface, sorry. And I already found the equation for this with reference to the point, which is 2, -1, -3, and we'll add that after this. But the equation for the tangent plane is 2x minus 2, multiplying that, plus 5 times y plus 1, and then minus 3, and that's all equal to 0. And then with that, I'm going to change the range just so we can see the, oh, gonna do -10 to 10 on each of them so we can see the plane extend a little bit further. And then you can do this however you so choose. Um, and we'll turn that on so we can see. It's kind of hard to see with this opaque, so we can go to settings and then do a constant color. So I will do this red. And even now, like it's kind of hard to see what's going on exactly. So I'm going to add the point so we can verify that it is tangent. And the point that this plane was made in reference to is 2, -1, and -3. And I'll make that black, and then we'll just size that up a little bit so we can see that. And the point is over here, so it looks like it's not on the graph. It is, just have to zoom out a little bit. And then you can see that the plane is only hitting it is tangent to this point, and you can just kind of move it around and see the different angles. Like it's a little bit difficult to see from this angle, but you can see it pretty nicely from this one. You can just see that the plane is hitting that point, and therefore it is tangent. Um, so that's all I have for tech demo number two. Thank you.